Find the time in seconds needed to increase the cart velocity. In this problem, a cart with a mass of 500 pounds has an initial velocity of 30 feet per second to the right. A hydraulic jet of water is sprayed at the cart at 80 feet per second, and we're asked to find how long it will take in seconds for the cart velocity to increase to 72 feet per second. From kinematics, we know the time it takes to increase the velocity of an object equals the final velocity, Vf, minus the initial velocity, Vi, divided by a constant acceleration, A. Since we already know the final and initial velocities, the last variable we need to solve for is the acceleration. From Newton's second law of motion, the acceleration equals the force exerted on an object divided by its mass. For this particular problem, we're dealing with the force of the hydraulic jet acting on the cart divided by the mass of the cart. From the problem statement, we know the mass of the cart equals 500 pounds. The force of the hydraulic jet equals rho v squared A. This force is occasionally written as m dot v or m dot delta v. In this equation, the term v refers to the difference between the velocities of the hydraulic jet and the velocity of the cart. Rho refers to the density of the fluid, and A refers to the area of the hydraulic jet. Since the cart deflects the jet of water at an angle theta, we need to multiply this force term by 1 plus cosine theta to account for this additional force. The acceleration of the cart is rewritten as dv dt and substituted into the equation. After rewriting our equation, we'll divide both sides by v squared and multiply by dt. After that, we'll integrate the left-hand side of the equation with respect to the velocity term, v, and we'll integrate the right-hand side of the equation with respect to the time, t. After integrating, we'll expand out the left-hand side of the equation, while keeping in mind the velocity, v, refers to the difference between the velocity of the hydraulic jet and the velocity of the cart. After expanding, we can isolate the variable for time, t. At this point, solving for t is a matter of plugging in the variables. From the problem statement, we already know the three velocities, as well as the mass of the cart, mcart. We were also given the angle theta, which equals 30 degrees. The last two variables are the density of the fluid and the area of the hydraulic jet. The density of water is typically assumed to equal 62.4 pounds mass per cubic foot. The area of the jet stream can be calculated since we were given the diameter of the nozzle. Therefore, the area of the jet stream equals 3.142 inches squared, which is the same as 0.02182 feet squared after converting. Solving for the time, t, we compute that it takes 20.6 seconds for the cart to get up to 72 feet per second. When reviewing the possible solutions, the answer is D.